All right. Section 12.1, we're going to start the statistics chapter. And we're going to be talking about sampling, frequency distributions, and graphs. All right. Definition: statistics, method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. We have two different areas of statistics. We've got descriptive statistics, where you are basically just collecting and organizing, summarizing. That's it. Then you're done presenting. As opposed to inferential statistics, where you're trying to make generalizations and draw conclusions from the data. So inferential statistics, that would be so this is what happened in the past. Inferential statistics would say this is what's going to happen in the future, or what will probably happen in the future. You got to be careful with inferential statistics because it doesn't always happen that way. So a population, some more definitions. Population is a set containing all of the people or objects whose properties are to be described and analyzed by the data collector. So, for example, if we are talking about the the students in a particular class, then the population would be the students in that particular class, which would be different from a population if we're talking about all of the students at CSN, then the population, all of the students at CSN. A sample is a subset of the entire population, and a representative sample is a sample that exhibits characteristics typical of those possessed by the target population. So if our population was the student, was all of the students at CSN, it's very difficult to speak to every single student. There's a lot of students. So instead of speaking with all of the students, we talk to a sample of the students. We just talk to, maybe we talk to 100 people as opposed to 30,000 people. But we want to make sure it's a representative sample. For instance, if all of the students we spoke with were taking math classes, that doesn't represent the entire population because not every student is taking a math class. Let's suppose we talk to all of the male students. Well, then again, that's not going to represent the entire population because, we're not talking to the females. So when we do representative samples, you got to make sure that that sample has the same characteristics of the target population. So we have a group of hotel owners in a large city. They decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So what would be the population? Well, the population is the citizens of that particular city. We wouldn't be doing citizens of a different city. We wouldn't be doing citizens of the county or the state. If we want to know how the citizens of the city feel, that's the population, the citizens of the city. Population is a set of all citizens of the city. All right. One of the hotel owners suggests obtaining a sample by surveying all of the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. And does this seem like a good idea to ask people at the 6 largest nightclubs on a Saturday night? No, actually, it's not a good idea. People who are going to, because they want to know, what the hotel owners want to know is how does the city feel about the hotel, or the casino. And if they're only asking people at nightclubs, there's a lot of people in the city that are not going to nightclubs. And people that are going to nightclubs would probably be more likely to approve of casino gambling, um, just because of the type of people that go to nightclubs. So, yeah, this would be a terrible idea to get a representative sample if you only ask people that are at the nightclubs. Questioning people at six of the largest centers is a terrible idea. The nightclub set is probably more likely to have a positive attitude towards casino gambling than the population of all of the city's uh, citizens. So, a random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected. So, one way to find a representative or random sample is to figure out the uh, uh, sorry, describe the elements of the population. So, do we have both males and females? Do we have younger people and older people? Do we have wealthy people and people who don't have as much money? Okay, so identify each element in the population. Assign numbers to each element in the population and randomly select those numbers. Assign the elements in the population who have those numbers to the sample set. So basically, you're just assigning numbers and randomly selecting the numbers. Okay, which of the following is the best way to select a random sample to find out how the city's citizens feel about casino gambling? Randomly survey people who live in the oceanfront condominiums in the city. Not a good idea. To um, think of this as being random because people who have oceanfront condominiums tend to be wealthier. The hotels tend to be on the oceanfront, so the oceanfront condominium people may not want all of the increased traffic that a hotel would bring. Um, yes, they might object to the increased traffic, the noise. It doesn't give each citizen of the city an equal chance of telling their point of view. How about surveying the first 200 people whose names appear in the city's telephone directory? By the way, they kind of mentioned this. They did actually do something similar to this in a prior election. Um, maybe in the 40s, the 50s. It was a while ago. And so they surveyed everybody with a telephone. Well, the problem was that only wealthy people at that time had telephones. So they were only getting the opinion of the wealthier citizens as opposed to the opinions of everybody. And so their prediction based on that survey was incorrect. Um, so the first 200 people whose names appear in there, you're not giving everybody an equal chance. Okay, you're not giving everybody an equal chance by looking at just the first 200 names. Randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. There you go. We have a winner. That is going to give us a random selection of the city. All right, constructing a frequency distribution. Okay, um, frequency distribution. We do this when we have a lot of numbers. So if we just have our numbers like this, it's really kind of tough to make any decisions based on the data because it's just all jumbled and we just don't know, can't see any trends, we can't see what's going on. So creating a frequency distribution, what we're going to do is we're going to figure out the frequency of each of our ages. Okay, so we look through here and we figure out what is the youngest age. Okay, so that is 10. 10 is the smallest number we have here. By the way, this is the age of maximum yearly growth for 35 different boys. Okay, so the smallest number we have is 10. So we look through and we only have one 10. Okay, so this frequency is the number of tens we have in our data set. Then do we have any 11s? We have an 11 here and we have an 11 here. So we have two 11s, and then we're going to look to see if we have any 12s. So we've got 1, 2, 3, 4, 5. We have 5 12s. You would continue doing this for all of the numbers. I'm going to cheat and go to the next slide. And here we have all of the frequency distribution. Okay. All right. Now, once we have it organized in this frequency distribution table, then we can notice some things. So there was, out of the 35 boys, only one boy had a maximum growth at age 10, and only one boy at age 17 and one boy at age 18. So not very many boys grew a lot of inches in height when they were 10 or when they were 17 or 18. On the other hand, right here, 9, there were 9 boys that grew the most number of inches in height when they were 14, and 7 and 6. So roughly speaking, these are the ages when the boys increase their height in how am I trying to say that? Maximum yearly growth. We'll call it maximum yearly growth. All right. So what are some conclusions? We talked about that. Number of boys who obtain their maximum yearly growth at a given age increases until age 14, and then it decreases after that. I'm going to stop here, and then I'm going to pick it up in another video.